Welcome back to Chem 2, Unit 4, Chemical Kinetics. Lesson number 2 on rate laws. This is video number 4, and we're going to look at another example or two on how to calculate rate laws. So here we're given 4 reactions, 4 experiments or trials, and we're given data on X and Y and the rate. So we want to find out what the order is on X, on Y, and we're calculating our rate constant K. So again, we can try the logical method. So if I look at our experiments, we may or may not use all of these trials or experiments. So if we look at 1 and 2, we can see that right here that these are the same and X changes. So in experiment 1 and 2, the concentration of X doubles. Y stays the same, and the rate goes from 6 times 10 to the minus third to 1.2 times 10 to the minus second. So this would be the same as 12 times 10 to the minus third. Be careful of the exponents. So the rate doubles. So if X doubles and the rate doubles, 2 to what power is equal to 2? X is to the first power. Now I have to look for 2 experiments in which X stays the same and Y changes. So the only 2 trials that X stays the same is 1 and 4. So that's what I'm going to look at. 1 and 4. The concentration of X stays the same. The concentration of Y goes from 4 times 10 to the minus fourth to 8 times 10 to the minus fourth. It doubles. If I look at the rates of these 2 right here, we have 6 times 10 to the minus third and 48 times 10 to the minus second. That would be the same thing as 48 or 4.8 times 10 to the second, 48 times 10 to the negative third. So that means that it goes up by a factor of 8. 6 times 8 is 48. So the rate is multiplied by 8. So 2 to what power is equal to 8? So that value is 3, 2 to the third power. So Y is to the third power. So now that we know that, we can solve for K. So we know that a rate, and I'm going to pick experiment number 1, 6.00 times 10 to the minus third molar per second, or we could use these units, it's the same thing. Moles over liters per second is the same as molar per second negative first, is equal to K times 1.00 times 10 to the minus second molar to the first times 4 times 10 to the minus fourth molar to the third power. So I just need to solve this using my algebra skills, and you should get K is equal to 9.38 times 10 to the ninth m to the minus 3 s to the minus 1. And if you start looking at this and you count the number of m's on each side, we have 1 to the first, so that's 1m, and we have an m to the third, so that's 4 m's on this side and 1 m on this side. So when we divide both of these sides, it'd be m over m to the fourth, which gives us 1 over m to the third, or m to the minus third. So you can use that to figure out what the units on K are. So if we wanted to report the whole rate law, we would say rate is equal to our K value times the concentration of X to the first, Y to the third. There is our final answer if we're asked to report the rate law. Now, if we look at example number 3, we're going to have to use the mathematical method for at least one of these. We might have to use it for more than that. So with this, if I look and try to isolate a reaction where only one thing changes, So I have three different reactants here. So two of them have to stay the same and only one can change. So if I look at this, the only one that I could use is 1 and 3. In experiment 1 and 3, the concentration of A is 0.2 and 0.2, and the concentration of C is 0.2 and 0.2. They stay the same. But if we look here, B is changing. B goes up by a factor of 3, and the rate goes up by a factor of 3. And if you can't figure that out on your own, put 7.20 over 2.40 and you get 3. So that means that 3 to what power is equal to 3? B is to the first power. So we know that B is to the first order. Now, if we search, we cannot pick any other experiments in which A and B stay the same and we can find C, or B and C stay the same and we can find A. So we have to use the math method to figure out these. I know what B is, so I can hold that one because we can put numbers in for B because I already know what the exponent is, but I need to find the exponent on C. So I'm going to pick two experiments in which A stays the same and C changes. So I'm going to pick experiment number 1 and 4. And I'm going to put the bigger rate over the smaller rate. This one's times 10 to the fifth, so that's the bigger rate. So 5.76 times 10 to the negative fifth is equal to K times A, which is 0.200 to some power, times B, which is 0.300 to the first, times C, which is 0.400 to, and I'm going to put the Z power. So that's experiment number 4. And I'm going to put that over top of experiment number 1. So we have 2.40 times 10 to the minus 6 is equal to K times A to the X times B to the first times C to the Z. So some things cross out. K crosses out, and the A values cross out. Everything else we could figure out mathematically. This value here is 24. 0.3 to the first divided by 0.2 to the first is 1.5. 0.4 to the Z over 0.2 to the Z is 2 to the Z power. So now to solve for Z, I'm going to divide both sides by 1.5, and I get 16 is equal to 2 to what power? 2 times 2 is 4, times 2 is 8, times 2 is 16. So Z is equal to 4. So that means that C is to the fourth power. So we have B, we have C. Now we have to find A. And we're going to use the mathematical model on that one also. So we are going to use math for 1 and 2. And if you want to pause this video right now and try to set this up, go right ahead. So if you pause this, this is what you should have set up. I put experiment number 2 over experiment number 1. And if we look at this, we end up with 6 is equal to, our K values cross out, 0.4x divided by 0.2x is 2 to the x. 0.3 to the first over 0.2 to the first is 1.5. And then 0.2 to the fourth over 0.2 to the fourth, that cancels out. So if I divide both sides by 1.5, I get 4 is equal to 2 to the x power. So I get our exponent is 2. So now I know a is to the second power. So now I have rate is equal to k times a squared times b to the first times c to the fourth. So overall, this is to the 7th order. And now I can solve for k. So I'm going to put the rate in 2.40 times 10 to the minus 6 moles seconds to negative 1 is equal to k times 0.200 molar squared times 0.200 molar to the first times 0.200 molar to the fourth. And now I can solve that, and I have 2 plus 1 is 3 plus 4 more m's is m to the 7th. I have 1 m over here. So my units on k are going to be m to the minus 6, s to the minus 1. And when I divide 2.40 times 10 to the minus 6 by 0.2 squared divided by 0.2 and divided by 0.2 to the fourth, I get 0.188. So there is my k value. Here is my rate law. We are done. You are now ready to work on this series of rate law worksheets on Schoology.